Good afternoon, friends. This is a series of lecture for 2IBC Analytical Chemistry student, semester 5 2019 pattern. And now in this lecture, we are going to learn about the chapter Gravimetry. This is chapter number 1. We have already learned some principles associated with the chapter, like common ion effect, definition of gravimetry, and the role of gravimetry in qualitative and quantitative analysis. Now here, solubility and solubility product principles we are going to study now. Before going to study, we must know about the solution, solute and solvent. The solute-solvent concept is applicable for the analytical chemistry student. A solute is a substance which requires a minimum concentration, while solvent is a substance, or okay, it's a solution type. It is liquid form and which requires a large excess form to prepare a solution. Now, solution is nothing but the addition of both solute and solvent. So, here, solubility and solubility product. The solubility of a substance at a given temperature in a given solvent is defined as the amount of the substance that is dissolved by known weight of that solvent when the substance is in equilibrium with the solution. Now, here, solubility is nothing but it is defined as at a given temperature and in a given solvent. It is defined the amount of substance that is dissolved by known weight of that solvent. That should be solvent should have we know the known weight of that solvent, and we have to add that solvent into that solution, and both solute and solvent at equilibrium with the solution. Now the unit of solubility is gram per liter or gram per 100 ml or mole per liter. Sometimes the solubility unit can be expressed in terms of gram per liter or gram per 100 ml, or we can say mole per liter. Now the saturated solution. When a solution at equilibrium contains maximum allowable concentration of a compound, the solution is said to be saturated solution. Saturated means maximum allowable substance that should be present in the solution. So maximum allowable concentration of that particular substance that should be present in the solution. So that is a saturated solution. Now here, sparingly soluble substance, it is our next concept. Now the substance which have the minimum or less or limited extent of the solubility in the solution, the substances are said to be sparingly soluble substance. For example, silver chloride, lead sulfate, barium sulfate, silver chromate are said to be sparingly soluble substances. Now, when such substances are subjected to water or can say any type of solvent, then we can say it makes the solution, or we can calculate the solubility product of particular sparingly soluble substances with their solution also. So here they are the sparingly soluble substances. This solubility is definite. Now these sparingly soluble substances have a definite solubility, and we can calculate the solubility as well as the solubility product. Now let us consider AB is a sparingly soluble substance, and this AB that should be dissolved in a particular substance, or we can say dissolved in a particular solvent to make up the solution. Now here AB that will undergoes with the equilibrium arrow. That equilibrium arrow is nothing but a double inverted, or you can say double headed arrow, which is the combination of forward direction and backward direction. So AB that can be dissociated into A plus and B minus ions. Now here again there is a one condition, that A plus and B minus, these ions that will come together to form a AB, that is sparingly soluble substances. So this is a particular condition for the solution. Now applying the law of mass action. Now here when we apply the law of mass action, here we get the K, that is equilibrium constant, and this equilibrium constant is nothing but the ratio of concentration of the product divided by the concentration of reactant. So if a concentration of A plus into concentration of B minus divided by concentration of AB. But here concentration of AB is this being a sparingly soluble substance, we can say its concentration remains approximately constant, and we can denote this constant as a K dash. It will be considered to be remaining constant. Now K is equal to concentration. We get that we can modify this equation in terms of K is equal to concentration of A plus into concentration of B minus divided by K dash. Now here K lies in the denominator, and this denominator K dash will be multiplied to the LHS K, that is K into K dash is This K into K dash is nothing but the solubility product. Now K into K dash is the solubility product and it is denoted by KSP. That is KSP is nothing but the solubility product for the sparingly soluble substance. Like in that example, AB is the sparingly soluble substance. Therefore, KSP that can be is equal that KSP is equal to concentration of A plus into concentration of B minus. So we can generalize for it for silver chloride. If we take the example that AgCl is nothing but the KSP of AgCl is equal to concentration of Ag plus into concentration of Cl minus. Or we can say if we take the example of KCl, then KSP of KCl is nothing but the concentration of K plus into concentration of Cl minus. So we can generalize for any particular sparingly soluble substance under investigation. So with this content, I conclude this lecture. Thank you very much for your patience listening.